Hello everyone. Today we'll discuss about the applications of graph in daily life. Let us find some applications. In everyday life, you might have observed that more you see a facility, the more you pay for it. If more electricity is consumed, the bill is bound to be high. If less electricity is used, then the bill will be easily manageable. This is an instance where one quantity affects another. Amount of electric bill depends on the quantity of electricity used. We say that the quantity of electricity is an independent variable or sometimes control variable, and the amount of electric bill is the dependent variable. The relation between such variables can be shown through a graph. Here, suppose this is quantity and cost. The following table gives the quantity of petrol and its cost. Number of liters of petrol 10 liters, cost of petrol in rupees 500. Number of liters of petrol is 15, then cost of petrol in rupees is 750. Number of liters of petrol is 20, then cost of petrol in rupees is 1000. When the number of liters of petrol is 25, cost of petrol is 1250. Right? Now you see, plot a graph to show the data. Let us take a suitable scale on both the axes. Suppose this is the x axis, this is the y axis. Then we are getting this point 10, 500. Here you see, this coordinate is 10 and 500. 10, 500. Right? This is the 10, 500. Next point is 15 and 50. Next point is 15 and 50 is this point. This is 15 and this is 750. Right? Next point is 21,000. Here you see, this is 20 and this is 1000. This point is 21,000. This is 25, 1250. Right? Now you see, mark number of liters along the horizontal axis. Right? Mark cost of petrol along the vertical axis. We have done the vertical axis also, and plot the points 0. This join the points. If we join all these points from origin, you find that the graph is a line. It is a linear graph. Why does graph pass through the origin? Think about it. The graph can help us to estimate a few things. Suppose we want to find the amount needed to buy 12 liters of petrol. Look at 12 on the horizontal axis. Look at 12 on the horizontal axis. This point is 12, and the cost will be rupees 600. You see, this is perpendicular to this, that means 600. Right? Therefore, we can find from P, you can take a horizontal line to meet the vertical axis. The meeting point provides the answer. This is the graph of a situation in which two quantities are in direct variation. In such situation, the graph will always be linear. In the above example, use the graph to find how much petrol can be purchased for rupees 800. Here you can also find that is 800 is this one, right? This point is 800. That means this one is 15 plus 1, 16, 17, 18, 19, 16. That means liters of petrol will be 16. In this way, you can find the various data from this graph, right? Now, question number 7. Principal and simple interest. Here it is given that sum deposited. Here the question is, a bank gives 10% simple interest on deposits by senior citizens. Draw a graph to illustrate the relation between the sum deposited and the simple interest earned. Find from your graph the annual interest obtainable for an investment of rupees 250. The investment one has to make an annual simple interest of rupees 70. Sum deposit 100. The simple interest for a year is rupees 10, 200 rupees 20, 300 principal, 70 rupees 30, 500 50, and 1000 rupees 100. We get a graph. We deposit in rupees 110, 220, 330, 550, and 1100. If you draw a graph, you will get this graph, right? That is, this point is 110. This is 110, this is 220, 330, 550, and you get a linear graph or a straight line graph, right? If we find this one, right? That means this is a straight line graph, right? Then we can get the various values for that, right? And suppose this one, if we take this one as 700, take a horizontal axis on this, that means the annual simple interest will be rupees 70 for rupees 700, right? In this we can find any value between this graph, right? Time and distance. Example 8. Ajit can ride a scooter constantly at a speed of 30 km per hour. Draw a time distance graph for this situation and use it to find the time taken by Ajit to ride 75 km and the distance covered by Ajit in 3.5 hours. Hours of ride, distance covered 1 hour 30 km, 2 hours 60 km, 3 hours 90 km, 4 hours 120 km, and so on. We get a value table of values 130, 260, 390, 4, 120. Scale we have taken horizontal 2 units equal to 1 hour and vertical 1 unit equal to 10 km. This one we got the distance covered in kilometer and time in hours, right? 1 2 3 4 4 units means 1 hour, right? We have taken 4 units, 2 units as 1 hour, and we have taken 2 units as 1 hour, and vertically 1 unit equal to 10 kilometer, 1 unit equal to 10 kilometers. This is actually 4 units. 1 2 3 4 4 units is 1 hour, right? This is 4 units, not 2. It is 4 unit equal to 1 hour, right? Plot the points 130, 260, 390, and 4, 120. You got the points, this one, right? Now you see, join the points, we get a linear graph. You see, this is a linear graph. Corresponding to 75 kilometers on the vertical axis, we get the time to be 2.5 hours. Here is 75 kilometers. This is 70, this is 75 kilometers, and you get the hours as 2.5. Between 2 and 3, it is 2.5 hours, right? And corresponding to 3.5 hours on the horizontal axis, the distance covered is 105 km on the vertical axis, right? If the time taken is 3.5 hours, 3.5, this one, right? This value, and we get the corresponding value is 100, between 100 and 110, that is 105, right? That is 100, we're getting as 105. Right, that is corresponding to 3.5 hours on the horizontal axis. The distance covered is 105 km on the vertical axis. In this way you can find or can read the various graphs. Dear friends, if you like this video, please subscribe, like, and share. Thank you everybody for watching this video.